In this video, we're going to take a look at different applications of quadratic functions and how we can use quadratic equations to model different situations and then use those equations to answer different questions and find different unknown values. So the first question we have here is about Mr. Cooper. And I'm going to have you pause the video and see if you can go through and pick out the important pieces of information in this problem. Alright, so we're trying to use skid marks to prove whether or not someone was speeding. And we're given our formula here, and for any kind of canned formula that you're going to use for a quadratic application, that will be given to you in the problem. You won't have to memorize these different formulas. So we have our rule that 1 over 24 times s squared equals d, where s is the speed of the car and d is the length of the skid marks. So we know the length of the skid marks and we're trying to find out the speed. So we're going to leave that s in there. But we're going to put in the 150 for our skid marks, and now we're just going to solve this equation for s. So we can multiply both sides by 24. We have s squared equals 3600. Now we've got that square term, so we can take the square root of both sides. We're going to have s equals plus or minus 60. Now in this case, it doesn't make sense to go with the negative answer, so we know that we're going to take the positive answer, which means that Mr. Cooper was driving at a speed of 60 miles per hour. So yes, he was correct in claiming that he was not speeding. Alright, this is where we get into more of the projectile motion that we'll spend a lot of time working with in this video. So again, go ahead and pause the video, see if you can pull out the important pieces here. Alright, so we have this acrobat, and here we are using our vertical motion equation. We'll use this fairly often, and again, this will always be given to you, but you do want to know that v stands for your initial velocity and s stands for your initial height above the ground. So we're going to take all of our information, plug it into this formula. We were asked in how many seconds will he reach a height of 70 feet. So we're solving for a value of t when h equals 70. So we can go ahead and set that up. So 70 equals negative 16 t squared plus our initial velocity was 64 times t plus our initial height, which was 6. So now the ways that we know so far how to solve a quadratic equation are graphing, which look at these large numbers, I don't want to do that. Taking the square root, and we don't have just one perfect square term where we can isolate our variables, so we're not going to do that. So that leaves us with factoring. As we learn more methods for solving, we'll introduce those into our applications, but for now, we're just sticking with those original 3. So we're going to need to factor this. And in order to factor, I need to get a 0 on the other side of the equal sign. That's always my first step. So in order to get that 0, we need to subtract 70 from both sides. So when we do that, we're now going to have negative 16t squared plus 64t, can't lose our variable there, minus 64. And now, just like before, I'm going to start by looking for a greatest common factor. And since my first term is negative, I'm going to want to take out a negative factor just to make my factoring a little easier. And I notice that all 3 of these values are divisible by 16, so I'm going to use negative 16. And instead of pulling that factor out and keeping it with me all the way down, since I have the equal sign, I'm able to divide on both sides by negative 16 and have that term drop out. So now we're going to have 0 equals t squared minus 4t plus 4. And now this becomes a fairly simple quadratic that we want to factor. And we're going to have 0 equals t minus 2 squared, because we recognize that this is a perfect squared trinomial. Or we could say we want factors of positive 4 that add up to negative 4, and that'd be negative 2 and 2. We get the same thing. So we take our factor, we set it equal to 0 using that 0 product property, and since this would be t minus 2 times t minus 2, I don't need to do the same thing twice. I can just do it once. So we set that equal to 0, and we get t equals 2, so that means the acrobat will reach a height of 70 feet in 2 seconds. If I wanted to check my answer, I could plug it back into my original equation and see if we got 70, but we won't ask you to check, we'll just ask you to answer the question. Alright, this is the same idea. Go ahead and pause the video, see if you can pull out your important information, and this time see if you can set up your equation. We'll solve it together. Alright, so we can pull out here our initial height of 2 feet, our initial velocity of 64 feet per second, And we're looking to see how long the rocket was in flight if it landed in a tree 30 feet above the ground. So we have h equals 30. And just like before, we're going to solve this one by factoring, so we need to get 0 on the other side of the equal sign. So we're going to subtract 30 from both sides, which gives us negative 16t squared plus 64t minus 28. And just like before, I'm going to look to see if there's a greatest common factor that I can divide on both sides by. So I see here that if I divide both sides by negative 4, it'll start to reduce my terms a little bit. So we're going to have 0 equals 4t squared minus 16t plus 7. And now we want to factor this equation. We're looking for factors of 4 times 7, so 28, that add up to negative 16. So we can change that to 4t squared minus 2t minus 14t plus 7, and we can factor by grouping. So if you look at our first group, we have a GCF of 2t, which leaves us 2t minus 1. In our second group, we pull out negative 7, so we get 2t minus 1 as well. So we end up with our two factors of 2t minus 7 and 2t minus 1. So now we can set each one of these factors equal to 0 and see what we get for our possible values of t. Oops, not minus 7 there. 2t minus 1. So here on the left with our first factor, we're going to get t equals 3.5. From our other factor, we're going to get t equals 0.5. So now it becomes a matter of how do we know which answer is the one that we want. So in this case, we have to think about what that flight of that rocket actually looks like. So we have our rocket here, and it landed in a tree. So the rocket launches up, and on the way down, it goes wrong and we land in a tree, and we land at a height of 30 feet. So this is where it's important to remember that our parabolas have symmetry. Every point on the left side of the parabola matches up with a buddy point on the right side of the parabola. So there are actually 2 points in the flight of my rocket where we're at a height of 30 feet. The first is on the way up, so that would be our t equals 0.5. Half a second into our flight, we hit 30 feet. When we keep going, we hit our maximum or our vertex, we start dropping, and on the way down, we also hit 30 feet, and this is where we land in the tree. So because more time has elapsed, this is where we're going with our second answer, our 3.5 seconds. I can't give you a one-size-fits-all kind of method for figuring out which answer is going to be the correct one. You just have to kind of use common sense, use the context of the problem to reason through and think about which answer you want. So for this problem, we'll answer that the rocket had been in flight for 3.5 seconds. And we always want to make sure that we include units with our answer when doing applications. Alright, for this one, you're going to try this one completely on your own. Go through, pull out your important information, write the equation, and then solve for the missing value. Alright, so we fill in all of our information into our vertical motion equation. And a clue here, and it was given to us in our hint, anytime we talk about hitting the ground or entering the water, we're always going to be looking at a height of 0. So we substitute that in for h, we put in our initial velocity and our initial height. We factor and we solve, and we get two answers, one that's negative and one that's positive. And since we want to know how much time has elapsed from her diving off to entering the water, we're not going to be going backwards in time. We want a positive time here, so we're going to go with 1.25 seconds. Alright, for our last question, we're looking at Angry Birds, and they follow a parabolic path when we launch them. We have one particular bird whose path follows the equation y equals negative x squared plus 29x minus 54, where x is the horizontal distance that he travels, and y is the vertical distance that travels. So we want to know the maximum height. So anytime we talk about maximum or minimum, that's a clue that we are looking at our vertex. And if we want to figure out that actual maximum height, we want the y-coordinate of the vertex. But in order to find the y-coordinate, we first need to find the x-coordinate, or the axis of symmetry. So we're going to use our axis of symmetry formula here. So we're going to have negative b, or negative 29 over 2a, 2 times negative 1. That gives us negative 29 over negative 2, or 14.5 for our axis of symmetry. So that means when we're at that maximum, we've traveled 14.5 feet horizontally. And now we need to substitute that back in to find the y-coordinates. So go ahead and try that now and see if you can figure out the maximum height that we reach. Alright, so after substituting in that axis of symmetry, or that x value, we get a y value of 156.25, which means if we add some units in here, we're going to reach a maximum height at that vertex of 156.25 feet.